Okay, let's continue with the part 2. Now we have configured this right side of this network so that IP phone 1 can communicate with IP phone 0. So IP phone 1 has the line number of 2222, where IP phone 0 has the line number of 1111. And we have seen in the previous lab session that we can communicate between these two phones because they are using separate voice VLAN. Now, if you can notice that I have connected these IP phones directly to the switch. Now, the specialty of IP phone is that they do have a normal RJ45 port just like any other switch or a PC, so they can be directly connected. Now, what if you don't have IP phone and still you want to use your analog phone? So in this case, we have to use something called the home voice over IP device, which will basically do the translation from analog phone voice data to digital data between the switches. So let me show that in the left side of the network, in R1 network. So I'm going to go to N devices and I'm going to get a phone. Now you can see the difference. Previously we took a 7960 IP phone, but this time we are taking analog phone. So this is analog phone. You can see the IP part is not there. So we are going to connect this. We are going to look at this. Now you can see the main difference is that there's no power connector, because if you think about the home phones that you have, they don't have a separate power connector, isn't it? So it's similar. IP phone will not have any power connectors. And the other thing is, we have only the phone cable. You can see this is the RJ11 cable. They don't have any RJ45 cable. That means if I take a copper straight through cable, I can't connect this because only port that I have is the port 0, which is a phone line RJ11. If I try to connect it, it says this cable cannot be connected. Now, to fix this issue, I'm going to add a home VoIP devices. If I go to N devices, there's something called home VoIP TT, which basically a translator between my analog phone and my switch. I can connect a home VoIP device using the Ethernet to my switch like this. Let's connect it to 2/1, and I can connect my home VoIP to the analog phone using the phone cable. If I use a phone cable, I can connect it to phone and port 0 here. Now this is a way of connecting an analog phone to a switch if you don't have IP phone. And the other way of connecting a phone is through a phone we can connect a PC. If you have an IP phone, through that we can connect a PC. So let me show you. If I go to N devices, if I get an IP phone and if I get a PC also, let's get a PC. So let me rename this PC to PC3. So PC underscore 03. That's our PC. Now I can connect this IP phone using a copper straight through cable. Let me connect this to 3/1. So I'm going to connect it to switch side, and I'm going to use the same copper straight through cable to the IP phone PC and to the pass Ethernet. So you can see you can connect a PC through an IP phone, or you can connect an analog phone using a home VoIP device. So this is the different ways of connecting. Now let's try to configure line numbers for these phones as well. So for the sake of this particular lab, I'm going to rename this to I'm going to assign the line number 3333 for my analog phone, and I'm going to assign the line number 4444 to my IP phone. Now there are a couple of things. I need to get IP addresses for my PCs. They should be able to communicate, and for that I have a VLAN called VLAN 88, which is data. And for the phones, IP phone 2 and analog phone, I need to make sure that I assign IP from the given block, which is voice VLAN 99, and they should be able to communicate also. So before I do that, I'm going to configure the link between, or the wide area network between R1 and R2. So you can see a 22.22.22.0/30 has been given. That means 30 means there are only two usable IP addresses, 22.1 and 2, which I explained in the previous session. Now let's assign 22.22.22.1 here to the serial 000 of R1 and 22.22.22.2 to the serial 000 of R2. So let's go to R1 and go to the CLI. Let's go to the global configuration mod very quickly. So I'm going to go to the interface serial 0/0/0. I'm going to say the IP address for this one. It's 22.22.22.1. It's 255.255.252 because it's a third network. And additionally, I'm going to set the clock rate of 64,000, and I'm going to say the port should be turned on, even though it's already turned on because I have turned it on previously, but issue the command no shutdown. Okay, let's configure the other side as well so that we can assign an IP for the serial 000 of R2. So I'm going to go to the CLI. Go to the global configuration mod. Let's go to the interface serial 0/0/0. I'm going to assign the IP address 22.22.22.2. It's again 255.255.252. No need to set the clock rate because this is a DTE interface. So I'm going to say no shutdown. It's to turn it on. So you can see we can communicate between these two routers. It's successful. Okay, now let's go ahead and configure the VLANs. Now you can see I have two switches. That means either I have to create both of this VLAN in VLAN 99 on switch 2 and in the switch 3 as well, or I can configure VTP so that I can send this VLAN information from one VTP server to a VTP client. So just to remind the VTP configuration also, let's go ahead and do that. So I'm going to configure my trunk ports first of all. So I have two trunk ports here, which is interface serial, fast Ethernet 0/1, the port which is connected to the router right here. So this port, switch side port, will be a trunk port. Let's use the range command, so it's easier for us to configure them together. And we have fast Ethernet 1/1. This port right here is also trunk port, so 1/1, and I can say switch port mode should be trunk. So these two ports will be converted into trunk ports. And I'm going to go ahead and say VTP mod should be server. I'm going to use this as server. It's already a VTP server because by default every switch becomes VTP server. And I'm going to say VTP domain, let's set it to VoIP just for the sake of this lesson. So I'm going to set the VTP domain to VoIP. Let's go ahead and configure switch 3 as well. So if I go to the global configuration mod, I can say interface fast Ethernet 0/1, which is the port which connects to the switch 2. It should be a trunk port. It's already a trunk port because of the auto negotiate. When we make this fast Ethernet 1/1 of the switch 2 into a trunk port, it automatically negotiates with the other side of the link, which is fast Ethernet 0/1 of the switch 3, with the port which are in now. So even though that auto negotiate is there, just for the sake of this particular tutorial, I'm going to go into the port fast Ethernet 0/1 of switch 3 and issue the command switch port mode trunk. Okay, now let's set the VTP mod. It should be a client mod, and VTP domain, it should be already there. For the sake of this, we'll type it again, VoIP. If it is already there, I should say that okay, it's already set up to VoIP because the server switch has communicated that information through the trunk ports to this particular switch as well. Now we have two switches configured. Let's configure the VLANs in switch 2 because that's our server switch. So we need to create two VLANs actually. So VLAN 88, the name should be data, and VLAN 99, name should be voice. So So we have these two VLANs created, and if the VTP is working, these two VLANs that we have created right here should go to switch 3 as well. So we can go to switch 3 and verify that information by issuing the command show VLAN brief, or in short shvlbr, and you can see the two VLANs that you have created just now, 88 and 89, are active and here. Let's go ahead and assign this correct ports to the correct switches. Now in the switch 2 we have already made the two trunk ports, but in switch 3, fast Ethernet 1/1, which is connecting to PC02, should be in the VLAN 88. So let's go to interface fast Ethernet 1/1. So switch port access VLAN should be 88 because that's data. And what about 2/1? Now here's the case. The 2/1 is not data, isn't it? It's voice. However, if we just say switch port voice VLAN 99, since this is an analog phone, we won't be able to communicate directly because it doesn't work with like a IP phone. So instead what I'm going to do is I'm going to say to home VoIP device, I'm going to say that use the voice VLAN as data. So it will use the voice VLAN data and convert it back and forth between analog phone. So that's why the interface fast Ethernet 2/1, I'm going to say switch port access. I'm not going to say voice because there's no point, because this is a modem. For that it's basically data, but it's not the data VLAN. The data should be voice data. So I'm going to say switch port access VLAN 99. Okay, so what about 3/1, which is connected to IP phone, but that phone is connected to a PC also. Now we have two issues. One, the PC should not access the voice data, the phone should not access the standard data. So what I'm going to do is I'm going to go into interface fast Ethernet 3/1, which is this port right here. I'm going to say switch port voice. Voice should be accessing the VLAN 99. Switch port access VLAN should be 88. So the PC should access VLAN 88 for the data. The phone should access voice VLAN 99 for the voice data. Okay, so we have those set up. Now let's go ahead and configure our router to handle the encapsulation. So I'm going to go to my router, say interface fast Ethernet 0/0. This is the gateway port. So we need to have two sub interfaces .88. So this is encapsulation .1q 88. Let's set the IP address for this one. So I'm again using the last usable of each block. For the data we have 199.99.99.0/24. So the last usable will be 254 with a subnet mask of 255.255.255.0. And let's go ahead and configure the other sub interface as well. So the interface fast Ethernet 0/0.99 and encapsulation on IEEE 802.1q encapsulation on 99, and the IP address should be, so the given IP block is 144.144.128 is the network address. It's a 25 network, so the last usable will be again 254. So it's a 25 network, so it's 255.255.255.128. Let's go ahead and turn on the main interface. So interface fast Ethernet 0/0. I'm going to issue the command no shutdown. So this will make sure that this port is turned on. So this fast Ethernet 0. One of the switch 2 is a trunk port. When we have two sub interfaces on the router, which is 0/0.88 and 99. Okay, let's go ahead and configure our DHCP server. So we need to have two DHCP pools, one for the data and one for the voice, just like we did for the previous session. So IP DHCP pool, let's call it as D pool for the data, and I'm going to say the network for this data pool is 199.99.99.0, and it's a 255.255.255.0 network, and the default gateway, default router is 199.99.99.254, and that's about it. And additionally, you need to exclude the address. So IP DHCP exclude address, because we don't want the router to use the 199.99.99.254 for the host, because it's already been used. Okay, so let's see whether it's working or not. So if I go to my PC, if I go to the desktop IP configuration, if I go to DHCP, I should get the IP address like this. So it's successful. I have gotten the first usable IP address. Now for this PC, I'm going to turn on this link later, and the PC should get the IP also. For now, I'm going to configure the other DHCP pool. So IP DHCP, let's call it as V pool, because this is for the voice data, and I'm going to set the network to it's 144.144.144.128. It's 255.255.255.128, because it's the 25 network, and the default gateway, default router for this one is 144.144.144.254. and remember, if it is a voice one, we need to set the option 150. So option 150 IP will be 144.144.144.254, again your gateway IP. And we need to set the excluded address. So DHCP excluded address will be 144.144.144.254, because that has been already given as the default gateway. So the phones also, we have created our DHCP. Now let's get the line number. So the first line number that I'm going to assign is for the analog phone number 3333, because it's usually it doesn't require separate power. That's why this IP phone is off, because we haven't connected the wall power. But for the analog phone, you don't need the power. As soon as you connect the phone cable, through that you are getting the power. So for that we will assign quick the number 1, number 3333. So I'm going to go with telephony service, and I'm going to say maximum E phones is again 2, because I have only 2 phones, and maximum DN direct numbers I need only 2, and I'm going to say the source address should be it's 144.144.144.254 on the port. I'm going to have to set a port. Now for the other side I have set the port 2000. For the ease of use, I can use the port 2000 here, but you can use any port number. Remember that it doesn't have to be 2000. It can be any random port number that is available for you to configure on your network. So I'm going to use port 2000 here. Let's configure the first one. So ePhone DN1. So I have to assign a number, but before that I have to do one more thing. So I'm going to exit very quickly. I will come back to this point. I'm going to go to home VoIP device, and if I go to the config tab, there is a place for me to enter something called the server address. So the server address is the default gateway of the accessing VLAN. Now home VoIP device on this particular 2/1 is accessing the voice VLAN. So the server address will be 144.144.144.254. Don't forget to issue that default gateway right here on the config tab of the home VoIP device. Alright, if you have entered that, we can go to the router and say ePhone DN1, the number is 3333. Okay, 3333. Now wait until you get the message called registered, so that the device will communicate and the phone will be registered. Like I said, it can take some time, up to 2 minutes, but even after 2 minutes it doesn't come in. There can be several reasons. One, your packet tracer configuration might be wrong, or there are some issues with the packet tracer software itself, which sometimes does not recognize these what you call VLAN configuration. Whatever the case, it doesn't matter. You can try it again and see how it goes if it doesn't work. But for now, give it somewhere around 2 minutes until you get the message called the phone has been registered. We will also do the same. We'll give it some time and see whether it's working or not. Try to send some messages first, see whether you can communicate. It seems like it's taking longer than I have expected, but nevertheless, you should give it 2 minutes and see whether it's working or not. Yes, actually I remembered a mistake that I have done. We didn't set the auto assign. Remember, so I'm going to exit from this for a moment and I'm going to go to my telephony service again, and what I have set is maximum ePhones to 2 and maximum directory numbers to 2, and I set the IP source address to this one, and I have to say auto assign, which we missed actually. Auto assign 1 to 2, isn't it? I forgot to do that. Let's try this again. So I'm going to say okay. Now you can see the phone has been registered immediately as soon as I assign the auto assign command. The reason was, if we don't assign the auto assign command, the router configuration, ePhone configuration, telephony service will not configure your phone automatically. Now if everything works perfectly, you should see in the GUI the number 3333 should be assigned. So that's that. So when you're doing it, it's better you give that auto assign command prior to issuing the ePhone DN1 command, issuing the line number. But nevertheless, if you miss a certain code like that, you can always go back and configure. As soon as you configure, the rest of it will work. Now let's go ahead and power up the IP phone 2. So I'm drag and drop this cable to power it on, and you can see as soon as I power it on, the PC also gets the power from from this particular port. That's also automatically turning on. Now we should be able to get an IP for the PC from the data VLAN and for the IP for the phone from the voice VLAN. So I'm going to wait until the ports all of them go to forwarding state before configuring anything. So give it 30 seconds so that these two ports are turning into a green color, indicating that they are in the forwarding state. Okay, now that has happened. I'm going to go to my PC, desktop, IP configuration, and I'm going to request an IP from the DHCP. Okay, so DHCP request successful. I got 199.99.99.2 as for my PC3. Let's configure my second ePhone. So I'm going to say ePhone DN2, and the number for this one should be 4444. Okay, again we are waiting till the registered command comes in. Okay, I got the registered command, which means it has recognized the phone and the line number 4444 has been assigned. Now if you go to your IP phone GUI, you should see the number 4444 is there. So let's see whether we can make calls between these two. So I have the analog phone right here and I have the IP phone right here. You can see the physically also there are a couple of differences between these two. The display size, and the buttons that you have here. Anyway, I'm going to make a call to 3333 and let's hang up. Let's call the receiver. Now you can see you're getting the call and they're connected. Let's hang the phone and let's try to make a call from this one. And you can see that is also working. Okay, so we can communicate between the IP phone and the analog phone. Now what about, since this network is connected, what about from one of these phones in this particular R1 network to one in the R2 network? Now if I try from my IP phone 0, which is bearing the line number of 1111, to my IP phone 2 in the R1 network, which basically bearing the line number 4444. So if I dial 4444, it simply says unknown number, right? And the same way, if I dial 1111, so it says unknown number. The reason for this is that they are in two different networks. Now you know, if you want to send a message from, let's say, this laptop to PC, it should get the message successful because they are in the same VLAN. And if you want to send a message from PC2 to PC3, that is also possible because they are in the same VLAN. However, you can't send a message from PC1 to PC2 here because we don't have any routing configured. Now we have learned that if you want to enable routing, we have to configure EIGRP or RIP version 2 or any other routing protocol like OSPF or BGP in order to communicate. However, even if you do that, you will not be able to communicate with the phones, because for the phone you need to design or rather define a voice routing protocol. Now just because you enable RIP or EIGRP here, it doesn't mean that you can communicate. So let me show you how to configure voice routing. Now we are going to use something called the dial pair for the voice routing. We have to do it manually in both sides. So I'm going to start with R2. Now in R2, if I go to my global configuration mod, sorry about it. Now in global configuration mode, I can issue the command dial pair. However, I have to remember one thing: the serial 000 port right here on the R2 is bearing 22.22.22.2, and this port is bearing serial 000 of R1 is bearing 22.22.22.1. Remembering that, I'm going to go with dial pair. So I can say dial pair voice, then we have to give a number just like similar to EIGRP autonomous number. Now this number can be anything between 1 to 1024. So I'm going to start with 1, dial pair voice 1. I'm going to use voice or IP. So you can see your prompt is changing from config to config dial pair. Right, so I have to say what's the session that we are working on and what's the target. So I'm going to say session target. I'm going to use the version IPv4 because I'm using IPv4 here. So I'm going to say IPv4, and then I have to say if I want to reach the target. Now we are reaching the target from this router. The target is router 1 because we are going to connect from one of these phones in router 2 to one of the phones in router 1. So the target is router 2's immediate port, which means the serial 000 port right here. Now that's why I asked you to remember, you need to remember the IP address that you assign to the serial 000 here, which is 22.22.22.1. So I'm going to say session target IPv4 is 22.22.22.1. And now I can set the destination pattern. Destination pattern means the destination line numbers that you want to connect. Now from this router, the destination line numbers I have two. I have 3333 and I have 4444, which you have to give manually. So I'm going to say destination pattern 1 is 3333. Okay, that's one destination. Now let's go to the other one. So dial P voice you can't use the number 1 now because number 1 has been used. I'm going to say dial pair voice 2 voice over IP, and session target is IPv4, and it doesn't change because the next target is 4444. That's also we have to go through router 1 serial 000. So it's the same session target, but the destination is now 4444. Okay, so we have introduced two destinations to the R2. So two destinations 3333 and 4444. So let's introduce these two targets 1111 and 2222 to the R. Go to the R. So I'm going to go to the R1 and let's say dial pair voice. Now again we have to use the number. Now we have used number 1 and number 2 in the router 2. That means we can use the same numbers here, but there's no rule. If you want, you can use a different number. Same number also can be used because that's a different router. So I can say dial pair voice 1 VoIP without an issue. If you want, you can use a different one as well. And again you can say session target is IPv4, and now when you are going to the target is in the R2. This is the first port that you are meeting, serial 000, and the port IP address is 22.22.22.2. so that's your target now. So it's 22.22.22.2, and the destination pattern is 1111. So that's 1. Let's set the other one. So dial pair, let's use voice 2 VoIP. Session target doesn't change. Destination pattern will become 2222. So you have set the voice routing as well. So this is how you set the voice routing. If you have 2 more phones in the both sides, there will be 4 more session targets that you have to configure. Now this is tedious if you have so many phones in your network. In that case, you can use a different routing protocol which makes it easier. But for any destination target, any number of targets, you have to set this. Now let's double check whether we can communicate. Now previously we couldn't make a call from 1111 to 4444. Let's try it again. I'm going to have both phones open in the screen. So I have 4444 right here and 1111 right here. So if I dial 4444, now you can see clearly I can make the call because the voice data is being transferred using the dial pair protocol to the other side, and also this side also you can make a call. So this is how you configure voice routing and voice over IP in your network, along with the dynamic host configuration protocol for the automatic IP assignment. So this concludes the voice over IP lab sessions for us. Make sure you create this, you configure this, and even if it doesn't work, try it again and again and make sure the file is working, because a majority of your online examination too will be based on voice over IP and dynamic host configuration protocol. If you have any questions, you can post them in the forum section which I have added, and I will answer them.